So in my last video, I was looking at this problem here where we started out just with a few points. So let me turn everything else off. We started out with just these 3 points in space, and then we found a vector that connects one point. Let's set these both to 0. That connects the origin to one of those 3 points, didn't matter which one. Turns out it was the green one. And then I used a direction vector, k, that connected it to one of the other points. In this case, it was the purple one. You can see the little vector points to the purple one now. And then I added a direction vector t that points it to the other one. So if I make k back down to 0, there we go. And what I claimed was that the vector that starts at the green point moves k steps in the direction of the purple point and moves t steps in the direction of the blue point, meaning the direction from green to purple, from green to blue, like direction vector AB and AC. If I allow both t and k to vary, that the endpoint of that vector is going to touch every point in the plane. The only way for it to truly touch every point in the plane would be for them to vary at different speeds and to vary, along all possible combinations. So that's not really happening in the program. It's going in some sort of cycle. But theoretically, you could think if I just let them slide through all possible values, you can see how that endpoint of that vector is touching all the points that are in a plane. Then what I did is I used the cross product, and I found this equation of the plane here, and you can see that the end point of the vector is tracing out a lot of different points in the plane, and that the 3 points lie in the plane. And so the cross product was one way to do this, but I mentioned that there is another way to do it without using the cross product. So I'm going to do that now. So what we're going to do is let's turn those off, just a little distracting, and let's start with our vector equation. And so our vector equation said our plane is a bunch of vectors that start at one point, the green point, and they move k steps in the direction of the purple point. So x goes up by 3, y goes down by 2, z goes up by 5, and they move t steps in the other direction. So from green to blue, x goes from 2 down to 1, so x goes down by 1, z goes down by 3, y goes down by 3 from 5 to 2, and then z goes up by 4. There we go, like that. And what I want to do is write that as a system of equations. The top row can be written as x equals 2 plus 3k minus 1t. The middle row can be written as y equals 5 minus 2k minus 3t. And the bottom row can be written as z equals minus 1 plus 5k plus 4t. And what I'm going to do is I'm just going to use like your basic Algebra 1 skills, your elimination skills, to get rid of k and to get rid of t, and eventually we'll get an answer that is equivalent to the one that we got with the cross product. Okay, so first I'm going to try to eliminate the letter t. And the reason I'm doing the letter t is because I've got a 1t term in the x. With the k's, I've got 3's and 2's and 5's, so I'm just going to eliminate the t. So what I'm going to do is I'm going to multiply x by 3 and then subtract y. So what I'm doing is I'm saying multiply x by 3 and then subtract y. So what happens if I do that? Look at each of the terms one at a time. If you multiply x by 3, you get the number value 6 minus the number value 5, you get 1. Then look at the k's. X times 3 means 9k minus y, so we do 9 minus negative 2, so that looks like 11k. And I know that the t's are going to cancel out because I chose the numbers that I did to make them cancel out. 3 times x would be 3 times negative 1t, so that'd be negative 3t, minus y minus negative 3t is 0. So now I have a second, or I guess a fourth equation technically. I have a new equation here that is valid, and it relates x and y, and it only involves the parameter k. What I need is I also need to involve the letter z. So I'm going to take x again. This time I'm going to multiply x by 4, and I'm going to add z to it. Because if I multiply x by 4, it'll have 4t, negative 4t, and if I add z, it will go, the t's will eliminate. So let's do piece by piece one more time. X times 4 means 2 times 4, that's 8, plus z plus negative 1 is 7. Now, look at the k's. 3k times 4 is 12k plus 5k is 17. And then the t's cancel out. Negative 1t times 4 is negative 4t plus 4t is 0. What I've done now is I've taken my 3 equations that had 2 parameters and shrunk it down to 2 equations that have 1 parameter. All right, 11 and 17 aren't super nice. They don't go into each other, and so I'm going to just multiply the top equation by 17 and the bottom equation by 11, and then we're going to subtract them. Okay? So if I multiply the top equation by 17, 3 times 17 is 51x. Y times 17 minus 17y. Let's actually just write them out before I combine them. 1 times 17, and then I guess 11 times 17, 170, 187. Okay, then the bottom equation times 11, 44x plus 11z equals 77 plus 187k. And now let's just go top minus bottom. Okay, 51 minus 44 is 7. Negative 17y minus, there's no y's in that bottom equation, so we just remain at negative 17y. Top minus bottom, there's no z's on top, so nothing minus 11 is negative 11z. And then 17 minus 77 is negative 60. And the k's cancel out because they're both 11 times 17. So we now have a new equation, and it's totally possible I made like a little arithmetic error, but let's see if it works. 7x minus 17y minus 11z equals negative 60. Goes through those 3 points. You can see that the vector, oops, you can't see the vector. There you go. Now you can see that the vector is going through the points on the plane. The plane goes through those 3 points. It's perfectly equivalent. The last question you might have is like, why do we get these 2 different forms of the equation? And that's just from the distributive property. So let's just go back, let's turn these puppies off. The distributive property just says that if you did like 7 times x, 7 times 1, 17 times y, 17 times 2, 11 times z, 11 times 3, you'd end up with 7x minus 7 minus 17y plus 34 minus 11z plus 33. Combining like terms, we get 7x minus 17y minus 11z plus 60. And that's all you needed right there. And that equals 0. So it's the same thing as the other version. Okay, thanks for watching. Please let me know if you have any questions.